Hi everyone, and good morning. Hope everyone is doing good. So, yeah, today, we are having the first session of the day, which is actually a pretty big session. So I will try to move as fast as I can. So we will see basically end-to-end data transformation. We will see how we can model our data warehouse. For this case, like Postgres or others, and what is DBT and how to use it, and some example demo that's going to help us understand it more. So as usual, if you have any questions, please don't hesitate to ask. Just raise your hand or just you can speak. And you see my screen? Okay, good. So yeah, so like if you can't hear me or if there's anything wrong with like if you cannot see my screen or so, just let me know. Yeah, so let's get started. So first, I want to see what transformation is and why we need this data transformation. Why is it important? So first, what's like data transformation? I think the data already, like the name already implies, like data transformation is transforming of the data. So we already have the raw data that can be like uncleaned or unstructured or the format is wrong and so on, which is just raw, which is fetched from like our API. It could be from our data lake or anything like that. So we already have that raw data, and it's the process of converting this raw data into a clean, structured, and usable format that can be used for another or further analytical purpose and reporting. So this is basically what data engineering is, right? So this transformation will ensure data quality, that end or the end result or the data that we get after transforming it is going to be consistent every time, and it's ready to be used downstream. So especially for modern architectures, especially in cloud platforms, transformation of frequently occurs directly within the data warehouse, which uses or leverage its processing power. So we will see. So this is basically like the transformation happening directly within the data warehouse, and outside the data warehouse is basically what's the difference between ETL and ALT, which is extract, transform, load, and extract, load, transform. So the mode architecture is extract, load, and then transform, which uses or utilizes the processing power of the data warehouse. So that's what we're going to be taking a look at. So why would we use transformation, and why is it critical? So as you may notice, like the raw data is usually dirty, like not clean. The format will be wrong. It can be like it could sometimes include duplicates. It could include some errors and so on and so on. So it could be unclean. It could have missing data or missing data points, incorrect data types, and the structure could be not good, for analytical purposes. So this transformation addresses these issues, which is like inconsistency, missing value, incorrect data type, and is not like to be structured for the operational system and for the analytical queries. So it's really important that we focus on this process, which is a transformation, which is a T in LT and ATL. Yeah, and performance for business intelligence and data science, it's very crucial. So with that being said about transformation, so let's see the two approaches that could be used in order to, in this process. So we have the ETL, which is extract, then transform, and then load it, which is the traditional approach. So as the name inclines or indicates, the raw data is extracted first, and then it's transformed in a separate staging area or a dedicated transformation server. So it needs an actual server. So it involves custom scripts or specialized tools, and then it's loaded into the data warehouse after the transformation is done. So this has some drawbacks, especially since it's resource intensive. It could be resource intensive depending on the amount or the size of the data. It's rigid and accessible for involving business needs. And when you come to the more modern approach, we can see that it can extract or transform, which is more of the modern approach. So here, as the name includes, the raw data is extracted and it's loaded directly into a powerful, scalable data warehouse or data lake. So it could be like these are all, of course, online platforms like Snowflakes. Yes, Abid, is that a question? Big queries, like Redshift, the Databricks, and so on. So the transformation is going to happen within that data warehouse. That means you could leverage their compute resource. So it offers enhanced flexibility. You can transform it on demand. You don't have to worry about loading it after transforming since it's already loaded. It's scalable. And because it uses cloud elasticity and retention of raw data for the future use and unforeseen analytical needs, you can actually, since you already have the raw data, you could work on unforeseen analytical needs. So one of the advantage here is the loading and transforming can occur in parallel. So this significantly speeds up the data pipeline. So this is very key thing. So the loading and transforming can occur in parallel. Here, the loading can happen only after the transforming is done. So this is just a visualization of this ETL and everything. So here we have the databases or the data lake that already has all the data. So the first step is extraction. So after you extract it here, it's going to filter or transform it. So it could be to filter, to join, to mask, things like that. And after it's loaded, you're going to it's after it's transformed, you're going to load it into the data warehouse. But here you extract it and then you load it, and here you're going to transform it by using tools like dbt. So dbt is the T in ALT. So here the focus could be schema creation, mapping, and automation, and so on. So this is basically the difference between ALT and ETL. Any questions so far, guys?
Yeah, sure.
Yes, of course.
Okay, so when to use ETL and when to use ALT? Is there any scenarios when to use which?
So if of course, if your business need is very rigid, for instance, if you don't need if the transformation is already known, like the input and the output is already known, the ETL could be a better choice, because it's designed for very rigid scenarios. But if you want the raw data to be loaded and used to different use cases, even for unseen analytical purposes, the ALT is basically the way to go. So the ALT has a lot of advantages, to be honest. Since it already stores the raw data and it's ready to be transformed into anything that you want at any time, it's what I would recommend. That's why it's called the modern one, and the ETL is called the attraction. Good question. Thank you for asking. Yeah, cool. Okay, I think we can move on. I'm planning to go faster, so if there's any question, please ask. Okay. Yeah, so let's talk about star schema. So star schema, you can imagine it to be uh, like a star, like where there is something in the middle and it's going to have arms. So that's it looks like a star. So I think I have already created. Sorry, let me actually get it. So I just one, okay. Um, an example that I have created for the demo. Yeah, here. It's not too. Sorry, just 1 second, okay. I just want to show you. Yeah, okay. Yeah. Go back here. Okay. Sorry, it was muted. So I was mumbling. Maybe that's why. Can you hear me now? Am I clear? Okay, good. So this was just an example star schema that I was trying to show you. So here we have in the center, you have the facts schema or data like table, and here we have the dimensions. So the dimensions are going to be linked with arms, and the facts is going to be in the center. So this is just an example of a star schema. I just wanted to show you so that you would have like a visualization of what it is while we move down, like the theory. So this is actually taken from the current demo session that we're going to have. Yeah, okay. So that's what I wanted to bring, and that's what caused a lot of chaos. Yeah, so let's talk about what it is. So the foundation of dimensional modeling, and we will see, of course, the facts modeling and so on. So this the dimensional modeling is actually the Kimball's principle that we call. This is going to design this design logic is going to help us structure the data warehouse specifically for optimization, optimized for analytical queries and business intelligence reports. So it prioritizes like understanding, query performance, extendability over strict normalization found in the transactional database. So we have two core concepts, which is facts, which I have shown to be in the center. So here is the facts table, which actually have the numerical measurements representing the business event. This is the example, okay, for the example, but it's normally a numerical column or a numerical table that represents, like an event, the business event. So when I say the business, don't just take it as like, that's why I'm struggling here. Like, don't take it as just to be in the monetary sense, or like, since the example is going to be in the uh, e-commerce business, don't take it as literal, okay? And the dimensions, which are the arms, are the contextual attributes that describe the fact. So in this example, we're gonna be like we're gonna be taking a look at the like the order like e-commerce table or e-commerce dataset. I think you can find it also in the Kaggle. So here, that's what we're going to be taking a look at. And we have the orders, which is the basically like the main or the numerical value of the business, right? For the e-commerce, it's going to need to know about the orders. So the orders, of course, has the orders, the customers, the product, the price, and the value, and so on. But these are all, yeah. And here for the dimensions, these are like what describes like which helps to describe the facts, right? So here we have the dimension of the customer. So for the customer who bought this order or who made this order, so we have the customer ID, the unique ID, the city and the state and so on, and others you can have. And for what did they offer, like what did they order? So that's going to be another uh, like uh, thing that you can use to describe the orders, right? So they order the product ID and the category name that you can say. So that's basically just an example of the facts, which is representing the like the numerical value that's going to represent the event in the dimensions, which is the contextual attributes that describe the fact. So the order could be described by the customers and the product that they bought. So when designing this, the Kimball's four-step design rule or method includes. So first, you need to have you need to choose the business process. So you need to identify the specific operational process, the business area, the sales, the inventory, this kind of thing, and this is going to help you define the scope of the data warehouse. And then, of course, you will have to declare the grains, so determine the lowest or the atomic level of the fact table that you want to include in your business event. And this is going to be used in the analytical flexibility. Okay. So for example, for sales, the grain might be one row per individual sales. So what is the row going to represent? One row going to represent. And after that, you can identify the dimensions, which are going to help you identify who ordered what, did they order, where did they order, when, why, and how, like this kind of thing. That's going to be used to describe the fact. Okay? And then, of course, finally, you can identify the fact. So here you can pinpoint the numerical quantity matrix that's going to be complete the fact table, and typically additive errors can be summed, average, and so on and so on. So this is going to be what we're going to be using. Okay. So what's the star schema? I think like we have seen earlier, it's the simplest and mostly used dimensional modeling technique. It has the central part table, which is the fact, and which is going to be surrounded by a multiple dimension tables. So as we have seen in the example. So it's very simple. It simplifies the complex analytical queries for business and BI tools. It optimizes the query performance and provides intuitive and understandable data models. So what we have discussed here. So for the benefits, like we have said, it simplifies the queries. It improves the query performance because it's like denormalizes the dimension table with fewer joins that are needed, and it facilitates data aggregation and reporting. It's very flexible and scalable, and it enhances understandability. So it's okay. Like we will see it in the example, so don't worry about it if it's like really new. But basically, this is what the star schema is all about. So here, let's talk about both the fact table and the dimension table before we move to the DBT part. So for the star, like the central part is going to be the fact table, which represents the business event. So this is going to be one factual table, okay? So it stores, so this is the key thing, numerical and quantitative data. It could be aggregated and so on. So it contains the foreign keys that's going to link to the primary key surrounding that dimensional. So for this example, it includes both the order item, no, sorry, the customer ID and the product ID, which are going to be used to link to the dimension. So to link to the dimension of the customers, it has the customer ID, and to link to the product dimensions, it has the product ID. So it has these keys to help to connect to the surrounding dimensional tables. So here is the key thing. Here is it has few row columns, but it may have millions and billions of rows, which means it's going to have events. And one thing that's really interesting about this, or which is basically key thing about this, is it adds row instead of like editing it. So that's another thing. So granularity, so it defines the level of detail for each row. So one row per sale transaction line item, or for your case, one row per image and so on. So you need to choose the right green for analytical flexibility. So choosing the right green is very key. And for the measures, so generally additive, so could be summarized across the dimensions, like quantity sold, transaction amount, and so on and so on. So these are some more of additives. Here it is. So like usually you append to a new data to the rows. You add new rows rather than add data. So this reflects the historical nature of the business event. So in a business, you normally add new roles rather than edit the previous ones. So that's the historical nature of the business events. So here, you don't have a lot of rows. As you can see here, you don't have a lot of rows. Sorry, columns. Like you only have like 5 columns here in this example, but it may have a lot of rows, like millions of rows. Of course, depending on the business. And for the dimension, it's a surrounding one. It stores descriptive, qualitative information or attributes about the entities. So who ordered it, what was ordered, where was it ordered from, and so on and so on. Or where is it, was the script from, and so on. So it's each dimension table has a primary key, which is going to be used to link to the fact table. It has normally it could be low in the row count, but it may have a lot of columns, and it's typically maybe stored in normalized instead of a separate column and category. So it makes it faster query and reduce the need for joinings. So this is crucial for maintaining historical data for attributes that change over time. So slowly changing the dimensions, it could be, but the dimensions will change. So this is just a practical step-by-step guide to design the star schema, which we have actually talked a little bit earlier. So you can go through it. I think it's already talked about earlier, so it's just a deeper dive. So I'm gonna pass through it. So identifying the business process and declaring the grain. So this has the smallest or the atomic size level of the row. So you need to identify what each row represents, and then you're gonna define. So actually, define the fact table, the dimensional table, and then establish the relations and validate the schema. So is that clear on the star schema, guys? Before we move to the GVT, I might be moving it a bit fast, so please ask. Okay, yes, Daniel.
Sorry, I joined late, but
Yes.
my question is, in the central, I don't know what to call it, but the central, let me call it the table.
The fact table.
Yeah, it's a fact table. Yes. So rows in the fact table, does that mean it's columns in the branch table?
No. Of course, like the rows could be defined like no, that's not how it works. So for the fact table in the row table, so these are entries like for the business, right? So whenever you like extract or fetch or scrape data from Telegram, it's rows, right? Like each row.
Yes.
So that's going to be connected. So that's going to be your business event. So that's events. And the dimensions or the arms are going to define what's already stated, like what's in the fact table. So you might not be more interested about where it came from. You might be only you might only have, you know, like the ID of that entry, but might not have the location or other events or other columns in the fact table, right? So in the fact table, you are more interested or focused on the analytical part of the business, right? So that's going to be your qualitative and for numerical value. That's, you know, like the business event that's going to represent the business event. But for the dimensions, they are more of a descriptive. So, for instance, I think this example is better. So here we have for the facts table, we have order, customer ID, product ID, price, and freight. So you might be interested in the analytical part for this, like for the business fact, you might be interested in this columns, but this can be further referenced or further quantitatively described by using the dimensions. So here for the customer, you may have the customer ID. So from the customer ID, you may have the unique ID and the city and the state. So you will have more information. So who ordered it, you will have it here. And what was ordered, you may have it in another. So it's going to describe. So there are more the dimensions are going to be answering who, what, where, when, why, how, and so on. So that they are going to represent the entries.
Okay, it's about defining the roles.
That's like it's not directly as that. That's why I'm struggling to say yes. But yeah, like basically it's going to define or it's going to help you like extend or have a contextual understanding about the factual table. Let's say that.
Okay.
Yeah. So for the order, you will have like for the who ordered it, you may have customer dimensions, and for what was ordered, you may have the product dimension. But for the orders which you are like focused on or primarily focused on, concerned about, you're gonna have it in the facts table. But in order to define or like to give it more context or to give it more to add more understanding, you may have you will use the dimensions, which are the arms.
Okay. Thank you.
Yes, Adenke?
Am I audible?
Yes.
Okay, to make it clear my question, let me ask my question in Amharic. Is that possible?
Of course. Yes.
እሺ ማለት ያው ከአንተኑ ከዚህ ከዳታቤዝ ዌርሃውሲንግ ሞዴል ጋር የተረዳሁት ነገር ኢትስ ሪቨርስ ኦፍ ኖርማላይዜሽን ነው አይደል? እና
Yes, denormalization. Yeah. Okay.
ልክ እንደ ፕሮሰስ ስንጀምር ቢዝነሱን መጀመሪያ አይደንቲፋይ ማድረግ ይለናል እና አንድ ካምፓኒ ዲፍረንት ኦፕሬሽን ሊኖሩ ይችላሉ። ፎር ኤግዛምፕል እዚህ ላይ እንዳለው የሴልስ፣ ኢንቨንተሪ፣ ከስተመር ሰርቪስ ኢንተራክሽን ኤንድ ሶ ፎር ኢች ፕሮሰስ ዊ ዊል ሃቭ ዲፍረንት ዳታ ዌርሃውሲንግ ሞዴል።
Dimensions. No, for each process you may have different databases, but you may have the same data warehouse.
So we will have a bigger data warehouse modeling in that
Yes.
case. Okay,
Yeah. So So you may think of it this so do you like the sorry let me ask so do you know like the difference between database, data warehouse, data lake maybe?
የስ ማለት
Okay, good. Okay.
ያው ዴታ ዌራውሱን አንስትራክቸርድ የሆኑ ዳታዎችን
No,
ስቶር
data lake.
ዴታ ሌክ
That's
እኮ
data lake.
አዎ
Yeah. Data warehouse structured.
ስትራክቸርድ የሆነውን በቴብል ፎርማት የምናስቀምጣቸው ዳታዎችን ነው። አሁን እዚህኛው ቅድም የተሰጠን ኤግዛምፕል ላይ ፋክት ቴብሉ ኢች ሮ ኤክስፕረስ የሚደረገው የሆነ ኑሜሪካል ቫልዩ ያላቸውን ሪካርድ ስቶር የምናደርግበት ሆኖ ዳይሜንሽኑ ደግሞ እያንዳንዱ ፎር ኤግዛምፕል ከስተመር አይዲ ካልን በዛ በአንድ ከስተመር አይዲ ስር የተገዙት የእንትን ስለገዛው ነገር ስለ ፕሮዳክቱ ወይም አይዲ ምናምን ሲሆን እንደዚህ አይነት ነገሮችን ዘርዝረን የምንይዝበት ነው ላይክ ዚስ ማለት ነው። የፋክት ቴብሉ ላይ ከስተመር አይዲ ብለን አዘ ፎሬን ኪ አድርገነው ዳይሜንሽን ቴብሉ ላይ ደግሞ በዛች አይዲ ዘ ዲቴል ኦፍ ከስተመርን ስቶር የምናደርግበት ነው። ኢናዘር ደግሞ የፕሮዳክቱ ላይ ደግሞ አዲሽናል እንትኖችን ነው። አሁን አክቹዋል ኖርማላይዝ የሆነ ዳታ ቴብሎችን ወይም የዳታ የቴብል ዲዛይን ብናይ ፕሮዳክት አለ፣ ካታጎሪ አለ፣ አይተም እንዲህ እያልን እንትን ያሉትን ቴብሎች ሰብስበን ወደ ቴብል አምጥተን መጨረሻ ላይ ፎር ኦርደር ለሚባለው ዳታ ዌርሃውስ ዲዛይን ወይም ስታር ስኬማ ለምንለው እነዛ የተበታተኑትን ሰብስበን እዚህ ላይ ዳታችንን መጨረሻ ላይ ፖፑሌት የማድረግ ሂደት ነው ብዬ ነው የምገነዘበው። እንደዛ ነው።
Yeah, you can think of it ለዛ ነው so database you can think of it as ቅድም የጠየቅኩት ለዛ ነበር like database you can think of it as structured ሆኖ ግን ለዲፓርትመንት ብለህ ማሰብ ትችላለህ so for the product department, for the customer department, for the you know like the other department ብለህ ማሰብ ትችላለህ ግን for the data warehouse it's structured ግን for the whole business ብለህ ማሰብ ትችላለህ right so ትክክል ነህ so we already have like if we already have the dimension the customer አለን ከዛ በኋላ ፕሮዳክት አለን so this could be extracted from የራሳቸው የሆነ databases right so የከስተመር ልክ እንዳልከው like የከስተመር database ይኖረናል የፕሮዳክት database ይኖረናል የኦርደር ይኖረናል ከዛ በኋላ እነሱን አምጥተን ደግሞ ከነሱ ውስጥ ደግሞ we will have የከስታር ስኪማ ደግሞ በምንሰራ ጊዜ we will have the fact table that's going to have the numerical አናሊሲሱን ለመስራት የሚጠቅመን ማለት ነው። is it breaking ያደረኩ ነበር?
እኔ እየተሰማኝ ነው።
Okay, maybe it's from your side. Yeah, so I think ጥያቄ ሳይሆን ኮንፈርሜሽን ነው። ያ ልክ ነህ ጀነራል።
ስለዚህ አሁን ኢቴል ለሚሆን የልቲ የመጀመሪያው ስራ አሁን እንዳልከን there is another database እነዚህ ኦንላይን ትራንዛክሽንን የያዙ ቴብሎች ኖርማላይዝ የሆኑ ቴብል አሉ። ከነዛ ቴብሎች ላይ ተነስተን እዚህ ጋር የስታር ስኬማችንን ክሬት ስናደርግ ለፕሮዳክት በሶስት በአራት ቴብሎች ሪፕሬዘንት የተደረጉትን አግሪጌት አድርገን ማምጣትና ከዛ በኋላ ከተለያዩ ጆይን አድርገናቸው እያንዳንዱ ቴብሎች ላይ ዳታችንን ሎድ ማድረግ ነው ማለት ነው።
ያ ግን አሁን ገና ኤልቲ ውስጥ ካልገባን ገና ስታር ስኪም ውስጥ ነው።
አይ በዛው ድጋሚ ቻንሱ ካላገኘ ጠይቄ ነው ታዲያ።
ኧረ ቻንስ አለ አይዞህ። ግን ያ you are right ያ በደንብ እንደውም ኤክስፕረስ አድርገዋል which is a good thing.
Thank you.
ያ እሺ thank you for I think እንደውም more ይሄኛው ኤክስፕሬሽን ነው more እንደውም በጣም thank you. So I hope that's clear everyone. ጥያቄ አለ ኮሜንት ላይ ሜሴጅ ላይ ነው ማለት ነው። Yeah, okay, good. Thank you, Mikael. Okay, so if this is clear, let's go to the DVD. So this is the transformation powerhouse of your data warehouse. You can see it. So DBT, which is short for data building tool, it's actually CLI. that's designed specifically for the transform stage in ETL. So you extract it, you load it, and from your database or from your data lake, data base or data warehouse, you're gonna be like transforming it. So it doesn't. So the thing here that you need to focus on, or understand about ALT. No, sorry, understand about DBT is that it doesn't extract or it doesn't load. Okay, so it just transforms. So it's going to happen after it's extracted and it's loaded just to transform it. So you need to have that in mind. Okay. So why? So some basic or core understanding about ETL. DBT is it's a SQL first approach. So it allows you to write the SQL query to transform the raw data into analytic ready data set directly within their data warehouse. So you don't have to load it. You don't have to extract it. You can work from directly from the data warehouse. It's best practices, so integrates principle like Git or version control, modularity. You will have testing. You will have documentation that's already built into the DBT. So it's a really good tool to use. And it's also have dependency management, so you can integrate it with DAG. So you can automatically build and builds a direct acyclic graph or DAG to your modules, so which ensures transformation ran in the correct order based on their dependencies. So you can actually make it to run in a specific interval and with the order that you have set. So you don't have to do it manually and you don't have to worry about the order. So if you have already set up DAG, of course, we don't have it. We haven't included it in here, but you can use Airflow and other DAG methods in order to execute them with order. It fosters collaboration. So if a new team, if a new engineer joins your team, like this is going to help you have standards of the transformation process and integrates with the version control, so that multiple members can collaborate and be up to date and on board. Of course, you will have single source of tools. So as I have said, it has already a built-in documentation. So this can be used as a single source of documented tools for the key business metrics and definition. So this reduces discrepancies across reports and increase trust in the data. And like I've said in the beginning, it doesn't load or extract the data. It's only does the transformation once the data is in your warehouse. So it should be extracted and loaded to be transformed. So for our example, we will use actually Postgres for our data warehouse. Yeah, so let's talk about some processes or layers, which actually we call them layers. That's going to help us achieve or get to the final result. So here we have 3 layers. The first one is staging. So the staging is going to be responsible for renaming the rows, cleaning them, or reducing the columns that we are not going to be using, creating materialized view, color tables, and so on and so on. And the intermediate is going to be actually the intermediate and the staging are more of similar, but yeah. So these are optional. Actually, most of the time we don't use them. If we use them, if there are complex multi-state transformations that cannot be done in a single staging model. And then we have the markers. Okay. So here we use a layers approach for data modeling, which significantly enhances scalability, maintainability, and reusability. So it's modular approach. Let's talk about the layers. So the first one is the staging layer. So this is going to be direct interface with the data source, which is the data warehouse. So the first point of interaction with the data warehouse is going to be with the staging. So it's going to stage, clean, and prepare a clean data that's going to be transformed. So here the function is to perform essential cleaning. It will handle nulls, remove duplicates, change the data types, rename the columns, and light restructuring. So the purpose of staging is to provide clean, standardized, and consistent view. So here, you have to. So I will actually bold this one. We're going to be creating a view of the raw data, making it ready to be more complex for the more complex transformation downstream. So here we will typically use source and then the source name and then the data table. So we will see this in the code, don't worry about it, to reference the raw table that's going to be found in the data warehouse, and it's going to be defined in the source.yaml file. So here for the materialization, often materialized as views. So here is the key thing. We don't really store the staging tables. We just store them as view or only materialize them. So this will help us avoid unnecessary storage, since it's just staging, as this typically are consumed by the downstream models rather than directly being queried by the end user. So so the next one is dimension models, which is building the descriptive context that we have talked earlier. So here we will create the dimension tables. Sorry. So here we are in the mark, okay, which is going to help us describe the context for our fact table. So we already have seen this. So I'm going to actually just pass through it. So it's often involves joining, transforming data from one or more staging models, or other intermediate if you have them, and consolidate them into all descriptive attributes into a single denormalized table. So this is what Michael was actually saying earlier. And the output is like a dimension Dutch. So this is actually what's recommended or standard. So dim actually refers to dimensions. So dimension product, dimension customer, dimension date, store, and so on. So these are going to be contain rich contextual information about each entry of the factual table. So this is going to use actually reference the downstream DBT model. So from the staging model, of course. So it's going to reference the staging model rather than referencing the data, the raw data that's found in the data warehouse. So the staging refers to the original data warehouse. That's for here for the dimension models and the fact models. They refer to the staging models. This automatically builds the dependency graph, ensuring DBT runs model in accurate order. So here, here it's not view, but it's actually materialized as or stored as tables. So this makes it efficient for querying. And the fact, it's the same thing. So it's the central fact table of the star schema, which contains the core business metric, and it will have it will also be stored in the table, especially for large data set. You could use incrementals, but you can store it in tables. So it could have so here the outputs is fact. So FCT is facts table, so it could be used for analytical querying and reporting. So it's aligned with a chosen grain of business process. So one line. So we have talked about grain or atomic level of the business. So that's what it is here. So here, like we're going to be using for like defining the models, like the dimension, the fact models are used in the macros. So these are reusable blocks of SQL or Jinja logic similar to functions stored in procedural instructional databases. So using this benefits us to not repeat ourselves principles. So it's reduces redundancy, it's standard. So it consists of applications and business rules, and it simplifies the query. It's flexible. It can be accepted arguments, like allow dynamic SQL generation. It will actually reside in the markers. We will see it actually in the use cases, just convergence, string cleaning, and so on and so on. So another like I would say advantage or another component of DBT is DBT testing, DBT documents. So DBT has actually built-in, like you can run DBT testers. We actually have two types of testers. The first one is built-in generic testing. The other one is business-defined testers. So it's DBT provides robust testing framework to validate the data quality and ensures transformation adhere to the business rule. So the customer ID should be unique. It should be like this and that. So it shouldn't be a negative number and so on. So it will ensure that the data that we have stored or the data that we have actually complies with the business rule and the data quality. So it will return the failing records. If the test returns zeros, it passes and so on. So if it fails, it will tell you why it failed and where it failed. So it will be, so the built-in generic tests could be general, like directly defined in the schema of the YAML file. We will see it actually. So some of the common or the known tests are not null if a column shouldn't be null. You would say not null. If it should be, especially for identifiers, identify columns, it should be unique. And if you have like a predefined list of accepted values, you can have accepted values. For example, for the tasks, it could be active or inactive or pending. So anything other than this should be flagged, and you should check it out. And the relationships, you can check for foreign keys values, and from one model to have a corresponding primary key in the reference model and so on. So for example, every product ID in fact sales should exist in products. So you can see this relationship actually. So these are tests. And the last one is documentation as a code. I'm sorry, I think I took a lot of time. Yeah, it's a big session. So document as a code. So you can actually generate documentation directly from DBT. So it's synchronized. It's like ensures the data is also in sync with actual data, discoverable collaboration. It will involve the teamworks to be provided by sharing understanding of the data sets. It will serve as a single source of tools, and it will help accelerate the onboarding process of a team members. So we will actually see that as well. Yeah, for the best practices, I think like we have talked about them, so you can actually go through them. Okay. So any questions, guys? I know I'm trying to be a bit fast because we took a lot of time, and we still have the demo. So is that clear, guys? Any questions? Anything that's not clear? No questions? Okay, good. Then I think we can move on. Yes, how we implement this. Henok, which one do you mean? The question is not clear. yeah, that's what we're going to be taking a look at in the demo. So can you see my screen? Okay, good. So so for the demo, I have chose to go with the I think Brazil e-commerce data set. I think I should. Okay, I will share the link. But it's basically the Brazil e-commerce dataset of Olist. The company is called Olist, so you can find it on Kaggle. That's my source. So here, what I actually did was I have downloaded them and put them in the seeds folder. So the seeds folder is actually meant to be used for, you know, like if you have static data. If you have static data, you can actually have them in the seed folder. And when you type in dbt seed, it will actually seed the database. So it's actually a reverse thing. Okay. So so what I'm gonna do is actually let me get out of this. So let me be here. So let me zoom in a bit, I think. So what I'm trying to do is I just wanted to show you what would happen when you start a new DBT project. So let me open a new one. Okay. Slash bin slash activities. Okay, so I'm in my virtual environment. So I wanted to show you what would happen when you initialize a new one. But for that, let me make a new directory and call it demo. And then we cd into demo. So here, sorry. So here, let me just initialize a new project. So as you can see, the first thing that's going to ask you is the name of the project. It should be an underscore and so on. So let me call it a demo dbt. So here it will ask you which database you're going to use, and it's going to take a look at your which is already existing. So when you install, you're going to install the it has adapters. So it is going to have adapters for different databases. So for me, I have I'm going to use Postgres. So I have downloaded the Postgres adapter. If you are using another one, you will just have to go to DBT and take a look at the adapters that they support and download that. So since I already have set up my profile here, so I'm going to choose one, which is my Postgres database, or for our case, my data lakehouse. Sorry, my data warehouse. And for the the host name, I'm gonna go with localhost. And for the port, I'm gonna use the existing port. And for the user, let me just choose the one that I'm going to use, and I'm going to give it my password. And for the database name, I'm gonna give it the data name that I'm going to use. I think it was DBT, so I have already created the database. So I'm going to give it the database name. And for the schema, I think that is DBT demo, I think. And for the crate, I'm going to go with one, and it's going to create. So what happened? So here it has updated my profile, the profile demo. to the profile.yaml file. So if you can see here, so okay, I'm going to change my password, but it has already created it here. So here, this is the project. For this project, it's going to use the DBT name. DBT is a database name, the local host, the host, the password, the port, the schema, the thread, like the type of the data warehouse, and the username. So it's going to store it. So if you make any mistake while you are creating, the project, you can just come here and edit it. Okay, you don't have to work forever. And to make sure that it has like your information is correct, the first thing that I would do is cd into cd into what was the name of the project of demo. Why is it not coming? Oh, okay. I think it's better. Yeah, cd demo slash demo. Yeah. Actually, let me first.
Kerod, where is the location or the path for profiles.yml?
It's going to depend, but it's going to give you the path here. It's going to give you the path here. So it's going to say the profile demo dbt is written to this profile. So it's going to be different, I can't say for sure, but it's going to be located in the .dbt folder. But your .dbt is going to, I don't know where it's going to store it in your case. But it's going to give you the link, the path here, okay? Did you find it? I think if you are following. Okay. So what I'm going to do is I'm going to say dbt debug. So here it's going to try to connect to the database, and it's going to check if it is going to work. And here it's connected, so it's good to go. Okay. So we have set up our project successfully, right? So after setting it up, so I'm going to come back to the original project, okay, here that we have seen. So the first thing that I did for my case, of course, since I don't have a data lakehouse that I extracted it from, I just came to the seed and already have it here. But in your case, if you already have stored your data in your database or your data lake, so like I know we're going to be using the same database for after we extract it, we're going to set it in that same database, and after transformation, you will set it in the same database. I'm going to use the right or the correct terminology. So for the data lake, the first one that you have used to store the raw data, if you already have it in a database, what you're going to do is you don't need to have these seeds, okay? So the seeds are where you put your .csv files that you already have as a static data. So these are static. So these are static. They are not being updated continuously, so they are static. So if you have static data, you're going to put them in the seed, and you're going to like say, actually, let me go back here and let me cd into all list and clear. Actually, And here, let me just say dbt seed minus 4. Actually, this is going to take a lot of time because it's a lot of data. But if you just say dbt seed, what it's going to do is it's going to load these already set those CSV files into my database, okay, into my Postgres. So it's going to upload them. So you can think of it as extractions phase. So it's going to extract them and put them in the or load them in the database. So the seed is going to do that. I think I already have opened Postgres admin. So let me just come here and here. So I have the dbt database here that you can see. And for the schema, I have two, the public one and the dbt demo, which I'm going to use. I think you have seen it. Okay, I have closed it. And in the dbt demo, in the table section, you can see the all list customer data set, like all list geolocation, order item, and so on and so on. So these, I think, 7, 1, 2, 3, 4, 5, 6, no, 1, 2, 3, 4, 5, 6, 7, 8, I think, or 9. No, 9, yeah. So 1, 2, 3, 4, 5, 6, 7, 8, 9. So these 8 files are actually what's extracted from here. Okay, 1, 2, 3, 4, 5, 6, 7, 8, 9. Yeah, I think 9 or 10. Yeah, but so these are like these are already. I had them as a static data, and I have used dbt seed in order to load them into my database. So these are actually loaded by using dbt seed. Okay, so that's what I just wanted to say. And then, yeah, so I have them. So I just ran dbt seed, and then I proceeded to write my models. So for my models, I have the staging models. So the staging, as we have said, are usually used to just clean, rename, the columns and so on and so on. So it's just for aimed only to use or to filter to use staging like the the tables that we only need. So before that, let me talk about the dbt project file. So this is also created when you already initially initialize the dbt. So when you say dbt init, I think you can see from the dbt demo as well. So here we already have the dbt. So here is going to have the profile that is going to use from the profile.yaml file that we have seen earlier, the name, the version, and where it's going to find the models, the analytic path, the test path, the seed path, and so on. So this is just telling it where it's going to find these things. And the target and the dbt package where so this is automatically created when you say dbt init. And for the models, it's going to have is going to tell it where the model is going to be stored. So here it is the demo dbt, and then from there we have the models, and then from there we have the examples. So here it says examples, and it's going to store them as materialized view if it is not specified. So this is the automatic setting. Okay, so here these two are actually created when you initialize the dbt. So when you say dbt init, it's going to create two example models. So here you can see the materialized table. So it has defined this as a table, so it's going to create a table. If you don't want, you can just leave it, and it's going to create a view. And this is just example which I have actually removed. So this is going to be when you create it. Okay, and for the schema, it's going to create this actually example as well, which you can edit later. So before, so let's move to our own. So here for the customer, so I'm gonna so remember when we talked about the staging. For the staging, we're going to use, or we're going to refer to the original data or the original source that's extracted from, like the data lake or from the seed or anything. But we're going to use the original data. So here you can see the source is actually DBT demo, which is the schema that we have created, and or is the customer data set, which is the table that we have created or that we have uploaded by using seed. So it's going to refer to the original data. And since we haven't configured it to be table, it's going to create a materialized view. Okay, it's going to be view. It's not going to be created as a table. So here I just from the source I have selected the customer ID, unique ID, zip code, prefix, the city, and the state, and I have renamed them to be the customer ID is just customer ID, the unique ID is unique ID, the city is the customer city is the city, and the customer city is the state, and so on. So I'm going to select everything from renamed and save it in the view. So here you can see it's not in the table, but if you go to the view, you can see it's in the customer in the staging customer column, right? So what I'm trying to do, yeah, okay. So here you can see it actually being used. So it didn't create a new table, it's just created a view. Okay, let me just refresh it. Okay. So this is what we did for the items as well. So I just used these things for the orders and so on and so on. So these are just staged from. So I think actually we have. Yeah, so these are just the staging, so I just renamed them. So I didn't do any cleaning here. I just renamed them. And after actually you finish with your SQL, you can run dbt run. So if you say dbt run, it's going to execute that query or that SQL query that you have written, and it's going to like create the view or create the table and so on. So if you say I think if you want to be to just have only one model to be run, you can just say dbt run dash the select, and you can state the model that you want to run. So here I just ran the stage orders model that you can see here, and it has compiled. So you can see that it's going to create the view. Since I haven't configured it to be table, it's going to create the SQL view, and it's going to finish. And if there is any warning or errors, it's going to tell you that this one passed. So it has created the view. So that's what happened. But if you just say dbt run, it's going to execute all the models. Okay. Yeah. So after that, what I did was I went. So before actually executing, what you have to do is you have to name or specify the after you seed, you have to specify the source that the data is going to come from. Okay. So here, what I did was for the source, I have the dbt demo schema, which is just a clone of all these. So this is a description, all these e-commerce. I will share a link if you need it, but if you just search it, you can find it. So for the tables, I have written all the 9 tables that are found there. And for the columns, if you want to run a test, so for the customer ID should not be len, and it should be unique. Sorry. It should be unique, and for the orders, it should be not null. It should be unique, and for the order status, like for the status, the accepted value are delivered, shipped, canceled, invoiced, and so on and so on. So these are tests, okay? So you can actually test the data. And yeah, so this is basically just defining the source. So you just have to define the column, the tables that you're gonna use here, and the schema that you're gonna extract it from. And then after you define it, you can just build by using dbt run, and you can actually test it off. Okay, after you run the staging, or before actually, you can also test it. But yeah, so here you can test it, and it's going to tell you which test is going, it's performing, and the time, and if it passed. So if you like, for example, in the schema, let's say, let's actually remove this one and save it and rerun the test. So it should fail. Yeah, so it has failed because there is the failed test sort of accepted value from the DBT demo or list order dataset. Order status, we have included shipped, cancelled, invoiced, and so on and so on, but it failed. It got one result that failed if it is not true. So false slamata, it has failed. So you can actually see where it failed and so on, and go and check it out. That's for our case, we can, since they delivered this part of the value that we accept, you can include it in the should pass. And yeah, for the marked, which is the final transformation phase. So this is just the cleaning and renaming and so on. So staging, so we didn't create any tables, but here for the marked, we're going to create the pacts and the dimension tables. So here I have configured it to be a table, so it's going to save that table. So here actually I didn't do much. So what I did was from orders, I got everything from stage order. So remember that when we said for the marked models, for the dimension and for the fact tables, we actually require the stage models rather than the original raw data set. So here I got the stage order from the third orders. I got everything, and from the order, the stage order items, I got everything as well. And here I selected the order items, the customer items, the order status, order, purchase, timestamp, approved delivery, courier, everything from the orders table that you can see. And from the order items, I got the product ID, the seller's ID, the price, and the price value. So here I have created, so I have actually merged, left joined, order items to orders, but where the order ID is the same. And I used that one for the product. I used the stage product model and used it to fetch ID, the product ID, the product category name, the product language, and others. And I merged the products table with the product category name translation table, where the product name category is the same. But for the customer experience, it's simple. I just used everything from the page customer table. So these are going to be the dimensions, and this is going to be the fact table. So actually we can see it here. So we have the fact order table, the dimension product table, and the dimension customer table that we can see here. Sorry. Yeah. So yeah, what else? So yeah, the documentation. I think I have also mentioned it here. So you can generate the documents and actually served it. So I think I have already generated it. So let me say community docs serve. So it's going to give me a URL on the local host. That's going to help me, like so they might want it. So for the earliest console, that one is what we have created earlier. For the analyst, for the models, we can see their a relation, if it is compiled, and so on, and what are like related to it. So for the customer, it's only depend on the stage customer. So you can see it from here, and from the source you can actually, for the compiled, you can see, okay, it's not compiled. So I have to compile it. So by compiling it, it's going to give you a query that you can run on the directly on the database or data warehouse. Okay. For the product dimension, it actually depends on two models: the staging product and the staging transition name. And for the facts table, is going to so this the analysis, but for the models, is going to depend on the order item and the orders. So you can actually see the relationship that they have and what is referenced by, if it is referenced. So you can see the upward and the downward. So here you can see actually the graph. I think let me go back to the order so you can see what came into it and what's actually total revenue time. And so this is what I wanted to actually analyze. So in the analysis, I have a model that's going to generate the total revenue by month. So with orders, so the facts order, it's going to select everything from the facts order, and for the product, it's going to select it, and what's going to do is it's going to by month, it's going to trunk it, and actually it's going to sum up the price, and it's going to generate the total revenue per month for that product, and it's going to give me and it's going to join the products and the product ID where the order and the product where the product ID is the same, and it's going to only fetch where it's delivered, and it's going to give me the revenue per month for that month. It's going to sum up the price. It's going to give me the revenue for that month. Yeah, so that's the analysis that you can see here, and you can actually, oh, it's not, yeah, here you can see it. So I think I have compiled. I didn't compile it. Oh, I thought I did. For the target, you can see the compiled, the analysis, and yeah, here it is. So you can actually take this and use it for analysis. So yeah, so that's it from my side. So how are you guys? Is it clear? So DBT takes care of all of it. Yes. So it pretty much takes care of the transformation fits. So is it clear, guys? Everyone's so quiet. Any questions? Anything that you want to go through? Yeah, it's very interesting. It's very, like, especially if you plan to work in data engineering, data science, you need to know this. Okay, so can we end the session? Is everything clear? I think the time is actually already close to the standard. So is everything clear? Can we wrap up the session? Are there any questions? Oh, okay, there's a question. So yeah, so the CSV is not dependency actually. It's not a requirement. So like I've said, it depends on the business. So for me, I already have a static data, right? But for you guys, you may be working with a dynamic data. That's, you may have a pipeline that's going to, like scrape Telegram data image. It's going to like extract the positions by using YOLO, and do that things. So it might be dynamic. So you might not use CSV files. Of course, you may use them if you just after scraping it, you download it into CSV and you like put them in the seed folder. Yeah, you can. But it depends. Like I said, if if your pipeline actually, for let's take an example. So if your pipeline actually extracts or fetches or what was the word? Scripts from Telegram and put it in your database for like, when I say database, it's like data lakehouse, or if it is extracted and put in your Postgres, then you do not need to have the CSV file. Okay, so the CSV is not like requirement, but you do need to have the data, and then DBT. That's all. So is that clear? Let's add it. So you basically need DBT as a dependence. Is that clear? Okay, good. Okay, anyone else? Any questions? I think we only have 5 minutes. Okay, I will take that as it's clear. Is it clear? Can you show me some thumbs up if it's clear? Okay, I will take that as a yes. Then. Thank you guys for joining. Actually, I would appreciate it if you just stayed, but I think I have to close it and open it again because we can have a different recording. So thank you guys for joining, and see you in 5 minutes. So I will actually open the meeting right away. So please join back. Okay. Thank you so much.